There's a number printed on the side of every inverter generator sold in America, whether you're comparing a Honda EU 2200i to a Predator 3500, a Champion 2500 to a Yamaha EF 2200 IS, or a Generac IQ 3500 to a WEN 56 200i. It's big, it's bold, and it's the first thing you see when the box arrives at your door. That number is technically real. It describes something the generator can actually do for about 3 seconds, maybe 5 if conditions are perfect. After that, the machine settles into a lower gear, a quieter truth that the packaging was never designed to tell you. The real output, the watts you can actually pull from the outlet for hours at a time, is buried on page 14 of the owner's manual. And it's anywhere from 15 to 25% less than the figure that convinced you to buy it. This isn't a manufacturing defect, it's a marketing strategy, one that works because no regulation in the United States says it can't. Every inverter generator carries 2 wattage ratings. The first is called starting watts, sometimes labeled surge or peak. It's the brief burst of power the machine can deliver when a motor-driven appliance kicks on. A refrigerator compressor can demand 2 to 3 times its normal draw the moment it cycles, and the generator has to absorb that spike without tripping. The second rating goes by several names in the industry: running, rated, continuous. But it describes one thing: the output the generator can sustain for hours without overheating or shutting itself down. It's the number that actually matters when you're sizing a generator, and it's the number the industry buries. The gap between the two is engineered into the product name itself. WEN's 56 200i is marketed as a 2,000-watt generator. Its running output is 1,600 watts. Harbor Freight's Predator 3500 carries 3,500 in its name. Its continuous capacity is 3,000. Even Honda's EU 2200i follows the convention: 2,200 starting watts, 1,800 running. Whichever model you compare, the figure that sticks in your head is always the surge figure, the one that lasts a few seconds at best. And there's a detail that almost never appears on the spec sheet at all: how long the surge can actually be sustained. 2 seconds? 10? Under what load? No manufacturer publishes a duration. The number exists without a time frame, which is a polite way of saying it barely exists at all. You might assume someone is checking these numbers. That somewhere between the factory floor and the retail shelf, an authority with testing equipment and enforcement power has verified what the spec sheet claims. That assumption would be wrong. The U.S. Consumer Product Safety Commission, the CPSC, does regulate portable generators. But the only binding federal rule, in effect, since 2007 concerns carbon monoxide warning labels. Output accuracy falls entirely outside its scope. The agency's own staff put it plainly in an internal briefing. There is no industry standard that relates a generator's rated power to the size of the engine, and there is no uniform way in which electrical output capacity is advertised. The closest thing to a performance benchmark is ANSI PGMAG 300, a standard maintained by the Portable Generator Manufacturers Association. It defines test conditions, specifies how voltage and wattage should be measured, and, as of its 2023 revision, sets stricter thresholds for automatic CO shutoff. What it does not do is mandate how a manufacturer presents wattage to consumers, and compliance is voluntary. A manufacturer can ignore G300 entirely and still sell generators at every big box retailer in the country. The result is a marketplace where each brand decides for itself how prominently the running figure appears, if it appears before checkout at all. It's not deception in the legal sense. It's something more durable than that: an absence of rules in a space where consumers assume rules exist. For years, the gap between the number on the box and the power at the outlet was something you'd only discover in the field, usually at the worst possible moment during a storm or a heat wave when the generator couldn't keep up. But independent testing has started to quantify exactly how wide that gap is. Consumer Reports ran lab tests on dozens of portable generators and reached a blunt conclusion. Under demanding conditions, some models fail to deliver the power that's promised. The Briggs & Stratton Q6500, a large inverter marketed at 5,000 running watts, earned a poor rating for power delivery. It couldn't handle a surge in demand anywhere near its advertised ceiling. Consumer Reports found this wasn't an isolated case. An entire class of 5,000-watt units fell short of their claimed output, and the magazine advised buyers to spend several $100s more for a model that actually delivers. Here on YouTube, the channel Project Farm ran a head-to-head with three popular 2,000-watt class inverters, a Honda EU 2200i, a Predator 2000, and a GenMax GM 2200i. All three were plugged into the same load, roughly 1,508 watts, comfortably below each unit's rated running output. The Predator tripped its overload protection and quit after 12 minutes and 45 seconds. The GenMax shut down around the 19-minute mark, apparently from overheating. The Honda ran the same load until it burned through its last drop of fuel at just over 32 minutes. It was the only machine in the test that did what its spec sheet said it could do. Part of the explanation was hiding under the hood. The Honda runs a 121 cubic centimeter engine. The Predator and the GenMax both use engines under 80 cubic centimeters, roughly a third less displacement, tasked with producing comparable nameplate numbers. The math doesn't lie, even when the label does. Even if a generator delivers its rated running watts in the lab isn't where you use it. Generator ratings are established under near-ideal conditions, close to sea level at moderate temperatures with a clean resistive load. The moment any of those conditions change, the real output drops. Altitude is the most predictable culprit. A naturally aspirated engine loses roughly 3.5% of its power for every 1,000 feet above the baseline elevation. At 6,500 feet, think Denver or much of the Rocky Mountain West, a generator rated at 4,000 running watts is down to about 3,220 before you've plugged anything in. Heat compounds the loss further, shaving off another % or so for every 10 degrees Fahrenheit above the rated ambient temperature. Then, there's a subtler factor that almost no consumer encounters until something goes wrong: power factor. Generators are rated in watts, assuming a power factor of 1.0. A perfectly efficient load. But most real appliances, especially anything with a motor or a compressor, operate at a power factor between 0.6 and 0.9. That means the generator has to supply significantly more apparent power than the watt figure on the appliance suggests. A 1,000-watt air conditioner running at a power factor of 0.8 actually demands 1,250 volt-amps from the generator. Multiply that mismatch across everything connected to the outlet, and the headroom disappears fast. I find this the most interesting part of the whole story, honestly. The wattage on the box might be exaggerated, but even if it were perfectly accurate, the conditions under which most people run these machines would quietly erase a chunk of that capacity anyway. So what does any of this actually mean for someone standing in a hardware store, looking at two boxes with two different numbers? It means the number on the front is the wrong number. The one that matters is the running wattage, usually printed somewhere on the side panel or tucked into the fine print online. That's the figure you size against your actual load, and even then, you want a margin of at least 20 to 25% above your continuous draw, because motor startups will eat into the headroom without warning. If you're running the generator above 4,000 feet or in summer heat, subtract further. The spec sheet assumes a world that doesn't sweat and doesn't climb. None of this makes inverter generators a bad product. The technology is genuinely impressive. Cleaner power output than the grid delivers in some rural areas, with total harmonic distortion typically under 3%, which matters if you're running sensitive electronics like laptops or medical equipment. Fuel efficiency that conventional generators can't match, noise levels quiet enough for a campsite at midnight, and an economy mode, sometimes called eco-throttle, that automatically drops the engine to a lower RPM when the load is light, stretching that fuel economy further still. Many inverter generators can also be paralleled together using a parallel kit, effectively doubling your output capacity by linking two identical units, something a single conventional generator can't do. And for propane users or anyone who wants flexibility at the pump, dual-fuel models are increasingly popular, running on either gasoline or propane, depending on what's available. For home backup specifically, none of these features matter much without one more piece of the puzzle: a transfer switch. Running a generator directly into your home's panel without a properly installed transfer switch is both dangerous and illegal in most jurisdictions. But that's a separate conversation the spec sheet never starts. The problem was never the engineering. It was the way the engineering gets sold in a marketplace where the biggest number wins the sale, and no regulator has ever stepped in. The next time you see a wattage figure on a generator box, do yourself a favor. Read it the way you'd read a politician's promise, with interest, but not without checking the footnotes.